Hi everyone, welcome to today's presentation, which is about the derivatives. In the previous lecture, we have learned about what are derivatives, why we need that, and how can we find the derivative of a function at some certain point. So, in today's lecture, we will do some exercises. We will attempt some question. So, question here is find the derivative of a function at point A if f of x is equals to 3x square minus 4x we have to find the derivative at point A. This is the point A. It could be some numerical number like 1, 2, 3, anything. And it could be A. So f of x is this. We have to find f prime of A. So what is the formula for finding the derivative of a function at some point? Formula is f prime of A is equals to limit h approaches to 0, f of A plus h minus f of A over h. This is the formula for finding the derivative. Now we will put the values of the function at point A plus h in A. So f of A is equals to 3a square minus 4a plus 1 and f of a plus h will be equal to 3 into a plus h whole square minus 4 into a plus h plus 1. We should simplify it. It will become 3 into a square plus h square plus 2ah minus 4a minus 4h plus 1 is equals to 3a square plus 3h square plus 6ah minus 4a minus 4h plus 1. Now put these values, this one and this one, on the formula. F prime of A is equals to limit h approaches to 0 into f of a plus h, which is equals to 3a square plus h square plus 6ah minus 4a minus 4h plus 1. F of a plus h minus f of a minus f of a is equals to 3a square minus minus plus 4a and plus minus minus 1 all divided by h. Now we can cancel some quantities, minus 1 with plus 1, minus 4a with plus 4a, 3a square with minus 3a square. And what are the remaining values? Limit h approaches to 0, h square plus 6ah minus 4h divided by h. Now you can see h is with every quantity. Here we have 2h, h into h. Here we have 1h and here we have 1h. We can take h common and then we can cancel this h with the other h. So it will become limit h approaches to 0. Take h common. This is h plus 6a minus 4 all divided by h. We can cancel this. And now just apply the limit h plus 6a minus 4. So this will become 0 plus 6a minus 4. So we get 6a minus 4. This is the derivative of the function at point a. So the question was, find the derivative of a function f. This is the function f at point a. So what was the formula? The formula was f prime of a is equals to limit h approaches to 0, f of a plus h minus f of a all divided by h. So f of a is as f of x equals to 3x square minus 4x plus 1. So f of a is equals to 3a square minus 4a plus 1. And f of a plus h is equals to 3 into a plus h whole square minus 4 into a plus h plus 1. We open the formula and this is, we get this expression. This is 3a square plus 3h square plus 6ah minus 4a minus 4h plus 1. Now we put these two values in the formula. What we get? We get this expression. By cancelling these values, the simplified form is h square plus 6ah minus 4h whole divided by h. Then we further simplify it and we get this expression. This is 4 plus 6a. This is not 60, this is 6a minus 4. Apply the limit as h approaches to 0. So it is 0 plus 6a minus 4. Next question is, find the derivative of a function at point a is equals to 1 if f of x is equals to minus x. Now we will do some more questions. Now we will do some more questions. So, what is the question is? What is the question is? So the question is to find the derivative of function. Derivative of function f of x is equals to x raised to power minus 2. Find the derivative of function at point A. This is the question. We have to find the derivative of this function at point A. So we will use the same formula. F prime of A is equals to limit h approaches to 0, f of A plus h minus f of A over h. So f of A is equals to a raised to power minus 2 and f of a plus h is equals to a plus h raised to power minus 2. These are the two values, f of a and f of a plus h. Now we will put the values in the formula. F prime of A will become limit h approaches to 0, A plus h raised to power minus 2 minus A raised to power minus 2 over h. Now you can see the powers are with negative sign. To make them positive, we can write it as limit h approaches to 0, 1 over A plus h raised to power 2 minus 1 over A raised to power 2 whole divided by h. The powers are with negative sign. To make them positive, we can write it like this. Now we will solve it. Limit h approaches to 0. Take the LCM. A square into A plus h square. This is A square minus A plus h whole square. Now simplify it. We will simplify it. This will become A square minus, open the formula of A plus B whole square. It will become A square plus h square, but plus minus minus h square minus 2AH over A square into A plus h whole square. Now we can cancel these values. Limit h approaches to 0 minus h square minus 2AA over h into A square into A plus h whole square. Now we can further simplify it. Take h common. This is minus h minus 2a. H into A square, A plus h whole square. This h and this h are cancelled. And what we get? We get limit h approaches to 0 minus h minus 2a divided by A square into A plus h whole square. Now we can apply the limit. If you want to simplify it, open the formula and multiply A square inside, but we can also solve it like this. Just apply the limit. It will become minus 0 minus 2a divided by A square into A plus 0. Okay. So this is minus 2a into A square. Okay. So this is 2a over a4, and this will become, we can, a4 is equals to a dot a cube. So we can cancel this a with this a. This will become 2a over a cube. We can also write it as 2a raised to minus 3, as 1 over a cube is equals to a raised to minus 3. So this is the derivative of that given function x raised to power minus 3 at point A.